welcome everybody. My name is Alex Gopinski, and I graduated with my master's in food science in December. And I came to the program with some other wine knowledge from different industry certifications, but I'm happy to be in the lab and working on more of the chemistry aspect of wine. I'm going to go ahead and get started. First, we're going to just explain how Brix and pH change during grape berry development and ripening throughout the growing season. We'll describe some optimal Brix and pH values to determine grape maturity. We'll go through some aspects of winemaking that are affected by pH, and then we'll have the opportunity for a hands-on portion. And if you have your equipment, wonderful. If not, just take really good notes, ask lots of questions. You'll actually be able to see me demonstrate how to use this equipment. We'll go through some calibration and then measure Brix and pH. And then we'll also talk about some waste management procedures. Okay, so to start us off here, obviously grapes, they grow throughout the growing season. They take time to ripen. And there are a couple main stages that I just kind of want to break down this picture here for us. So we talk about development and ripening a lot of times when we're talking about grape maturity. And so the first part of grape growth is development. So we have that sort of before the veraison period, which is that middle time point in the summer sometime when the color in red grapes start to develop, berries start to soften, and sugar starts to accumulate as well. And that's when we enter that ripening phase. So we're concentrated on sugars, balancing it with the acid, which is that blue line. We'll have organic acid content decrease, which makes pH go up. And we'll explain all of that a little bit more and how that works in a few moments. So sugar is a big thing that everybody will think of when you're thinking about ripe fruit. And that contributes to total soluble solids. Total soluble solids is just the stuff that's dissolved in grape juice. So it's about 80% water with about 20% dissolved solids. And that 20% solids consists of sugars, organic acids, phenolic compounds, which are like the color compounds, tannins, nitrogenous compounds like proteins, and structural polysaccharides, similar to pectin is one example. So of that 20%, about 95 to 99% of that is sugar. The two main sugars, I have the figures here, or the structures here on the slide, glucose and fructose, which you may recognize, but if you don't, they're just the building blocks for sucrose, which is white table sugar, but those are the fruit sugars. And so if we want to measure how much sugar is in our grape juice or wine, we do that by assigning a unit to it called Brix. That's the most commonly used in the United States. There are other units, but Brix is what we typically talk about. And 1 degree Brix is 1% solids in the solution, which is 1 gram per 100 grams or 100 milliliters of the solution. So another way to think about that is that it's a measure of density or stuff per unit volume. And when you're thinking about it in terms of density, you might recognize that it's temperature dependent. So when we're measuring Brix, it's really important to know the temperature of your sample because colder things are denser. So you might get a higher degree Brix reading if you measure a sample that just came out of the refrigerator versus one that's been sitting out on the counter and you're measuring it at room temperature, which is 68 Fahrenheit or about 20 degrees Celsius. When we're approaching harvest, we want to know what to expect. What values are we looking for? Now that we know what Brix are, but when we get to about 150 to 200 grams per liter of sugar content, which is about 15 to 25 Brix, and that can get higher depending on which cultivars. So I heard a couple people introduce 21 different cultivars they might be working with, a few plants of each. Others might be concentrated on 1 to 3 cultivars. So really knowing which cultivars that you have and which values to expect. So for example, in the table, Marquette, which is one of the most popular cold hardy grapes grown around the Midwest and in Iowa specifically, you can expect a Brix, just over 20, 21, 22. I have seen it as high as 26, but that was letting it hang for quite some time. compared to something like Edelweiss, which is a white cultivar. So if you're going to wait for your Edelweiss to hit 20 Brix, you'll be waiting a really long time. So it might be time to harvest that Edelweiss a little bit earlier than those other cultivars. The other thing that the sugar content will tell us is that we can predict how much alcohol, if we ferment that juice, that we'll get in the wine. So if we take our Brix, our degree Brix, and multiply that by 0.57, we can get an estimate for the amount of alcohol. And that conversion factor will change a little bit depending on the cultivar and the yeast that you use. That conversion rate of sugar to alcohol does change a little bit depending on what else is going on in the fermentation. But 0.57 is a good average. So with the range that I have it as an example on the top, we have 15 Brix. If we harvest our grapes at 15 Brix and we multiply that by 0.57, we end up with 8.5 expected alcohol by volume, or ABV, versus the 25 times 0.57 is 14.25. So about a linear relationship. It's almost double the Brix, so you're almost doubling the alcohol. But that's a good estimate to predict how much alcohol you're going to get. And so you can modify your picking decisions based on cultivar, wine style, and just kind of overall what you want to get out of the harvest. So how can we measure this? There are several tools that we can use to measure total soluble solids. The most basic is a hydrometer, which is a glass tube filled with a gas. It's got kind of a bubble there, and that just floats in the liquid in the juice. And wherever the surface of the liquid crosses the scale, that's your Brix measurement. If you've got one that has a specific gravity or a density measurement, you can use those as well. But just understanding which units that your hydrometer is giving you, so you can record those same things and then compare values with the same units. Additionally, another note with hydrometers is that oftentimes they only go through a specific range of Brix. So you might need a couple of them if you're going to use them to monitor your fermentation. So if you harvest at 25 Brix, that same hydrometer won't necessarily be able to tell you when you've hit 0 Brix or fermented to dryness. So you might need a couple different hydrometers that will go through that fermentation with you. Next is a manual refractometer, which I'll demonstrate today. You see that here. Those are really easy, really handy to use when you're out in the vineyard. You can use them in the winery too, of course, but they're really good to just go on the go. Just take the grapes and just squeeze a couple drops of juice directly onto the lens, and you can use it out in the daylight really easily. The next tool is a digital refractometer. So a little bit more expensive, but it's doing more work for you. I mentioned that the Brix or soluble solids measurement is temperature dependent. So with both the hydrometer and the manual refractometer, you might have to do a little bit of an adjustment depending on the temperature if you're measuring your sample not at 20 degrees Celsius. Whereas the digital refractometer will most likely have a thermometer built into it, so it will do that adjustment for you. Definitely taking a step up in the budget is a densitometer. Anton Par is a common one, but I don't think it's the only brand out there. A little bit more expensive, but they do a lot of things. So not only are they going to measure Brix, they'll measure gravity, density, alcohol, a whole bunch of different things. But that's a handy tool as well if you're doing a lot of fermentation to just quick measure everything as you go through. So in addition to sugar, organic acids also contribute to total soluble solids. The primary acids in grape juice are tartaric and malic acids. You see the structures there, and they account for more than 90% of grape acidity. There's also a little bit of citric acid that's naturally present in grapes, but most of the time that's consumed by fermentation. However, winemakers can choose to adjust the acidity of their wines if necessary by adding citric acid. That's one of the most common acids to add for adjusting. Succinic acid is produced during yeast fermentation. Lactic acid is produced from malic acid during malolactic conversion or malolactic fermentation, MLF. You may have heard of it. And then acetic acid, that's produced by spoilage, acetic acid bacteria. So generally, you don't want that. It's when we start getting a vinegar or volatile acidity aroma. And that's generally a flaw, which can lead to faulted wine, something that you won't be able to sell or use. So we'll talk a lot more about acids and how they contribute to titratable acidity in the next one. But for this workshop, we're going to talk more about pH. And that's the power of hydrogen, or pouvoir hydrogen, which is where pH comes from. If I go back here to the acids, you'll see the little H's on the molecules. And that's where we get this H plus in the equation. And I don't want equations to scare anybody. We're not going to do too much math today, but it does serve a couple important roles. So one, this pH equals the negative log of the hydrogen ion concentration. That's what that means. And you may have seen the pH scale, which goes from 0 to 14, with wine here at about 4. You can kind of see that among some other common household items. But that log base 10 operator in that equation, that tells us that it's a logarithmic scale. And that's really important to understand because the pH of a value of 3 is 10 times different than a pH of 4. So a pH of 3 is 10 times more acidic, more powerful. The hydrogen has more power than pH of 4. It's a really big difference in terms of acid strength when you only change 1 unit in pH. Typically, the hybrid grapes that we're growing in the Midwest and cold climate regions, they're going to tend to have higher acid content, so lower pH, than the typical Vitis vinifera grapes that are grown in southern parts of Europe, in California, everywhere else pretty much in the world. And then additionally, you can see the pH scale at the bottom, kind of shows you different styles of wine, with white wines tending to have a lower pH than red wines. And so again, just giving you some parameters or some numbers to look at for common cultivars grown in our area. Marquette being 3 to 3.3 at harvest, and then Edelweiss or La Crescent going a little bit lower than that. If you're waiting for these cultivars to bring up the pH, you're going to be waiting a while. But another note, especially in Edelweiss that I didn't mention earlier, if you're waiting for those Brix to come up, you risk Edelweiss developing a really foxy aroma. So to capture it at its optimum ripeness with the aromas that you want, and then also the chemistry parameters that you want, just keeping an eye on those. Okay, so why does pH matter for winemaking? Well, small changes in pH of like 0.2 can lead to really important changes in your winemaking decisions. So I mentioned that pH is on a logarithmic scale, which means that a difference of 1 is a 10 times difference in acid strength. So here I'm talking about differences of 0.2. And if you look at the table in the bottom left, you'll see as we go up from pH 3 to 3.2 to 3.4, if we want to get the same amount of protection from sulfur, so the molecular sulfur dioxide, we'll talk a little bit more about the forms of sulfur dioxide in workshop number 3. But in order to get the same amount of protection, so either 0.8 or 0.55, whatever you decide is your target, you have to add about 1.5 times more as you go up by 0.2 in pH. So I go from needing to add 13 parts per million of free SO2 to 21 to 32. So there's a big difference in how effective sulfur dioxide is. Additionally, pH will affect how your fermentations go. So both your primary alcoholic fermentation and secondary, if you're going to go through malolactic fermentation. So microbes have a happy zone where they work the most efficiently, and keeping the pH in the range that you want for the microbes that you want to be doing the work, and then outside of any spoilage organisms, Brettanomyces or something like that, if your pH gets a little bit too high, different organisms can start to take over. So also color, especially for red wines, the anthocyanin pigments are the brightest, the most vibrant that they can be. in more acidic conditions. So again, you might start losing more color if that pH creeps up too high. pH also affects protein and tartrate stability. It's related to the taste of sourness. So we're all familiar with the taste of a lemon. That's acid, sour. And so the lower the pH, generally the more sour the wine will taste. And then microbial stability. Again, back to the fermentation thing, but also once you're completely done, your wine is finished, you want to make sure that the pH is in a good range to avoid any spoilage organisms coming at your finished product. So we can measure pH in a couple different ways. The most convenient and easy way, quick and easy, is to use pH strips. However, you'll notice, we talked a lot about the difference in pH range. And here we're going from 2.8 to 4.4, and there are only 4 or 5 different colors here. So it's not very specific. It's not very precise, and it's kind of subjective to what color that you're going to assign to that reading. So if I say it looks like it's the green for 3.2, and you say it's 3.6, that's going to affect our winemaking decisions in big ways. So more precise way, better way is to use a pH meter with an electrode. And that's just measuring the strength of voltage between the electrodes in the probe based on the amount of charge that there are hydrogen ions. So they're little charged particles that are buzzing around in your grape juice. And it's just measuring the electricity basically going between those. So before we switch over to the demonstration portion of the workshop, I just want to go through a few basic lab safety and best practices for using this equipment. So first, we understand it looks like a lot of people are in their homes today, but even if you're in your winery, we know that it's not the same as a chemical laboratory on a campus. You don't have all of the same chemicals present, the same systems for dealing with waste in place, but it is still important to understand what you're working with and to protect yourself and those around you. So using gloves, and grape juice is really acidic, does irritate your skin if you get it on you. So wearing gloves, eye protection, closed-toed shoes, good idea, especially if you're working outside in the, with the heavy equipment. Hopefully everyone's doing that anyway. But to protect yourself from spills, pants and closed-toed shoes are a really good idea. Lab coat if you have one, but maybe you just have a designated flannel for that corner of your winery where you're doing chemistry. Using distilled or deionized water during your chemistry measurements, this really helps to avoid mineral buildup, which can lengthen the life of your instruments and increase accuracy and precision for your measurements. Additionally, just thinking ahead to data recording, have somewhere where you can record the values that you get today so we can share and compare and talk about why values might have been alike or different. But a little bit more big picture, thinking about your own operation, having a designated notebook for all of these measurements to record, one that you can take with you into the field and then bring back to the computer, type it into Excel. There are calculations involved in anything. You can really streamline those with an Excel sheet. And then thinking about comparing, different cultivars from year to year, what my, the rate at which my Marquette ripened this year might be different from last year or next year. And so just being able to kind of track that and get a really good idea of how your grapes are behaving in your location over time. So lastly, the waste management. Again, just being comfortable and familiar with the stuff that you're working with, referencing your safety data sheets or SDS and your local guidelines. So the SDSs will give you, they either come with chemicals that you'll order, or you can easily just Google SDS and the chemical name pops right up. Try to look at the ones specifically for the same manufacturer, even though several manufacturers will make sodium hydroxide, for example. So today, specifically, we're going to be looking at pH buffers. And so those are toxic to freshwater fish, according to the SDSs that I checked. So just being conscious of that, try not to dump those down the drain. Similarly, the pH meter reference and storage solutions. The storage solution that's in the little vial at the end of a probe, that's commonly potassium chloride. And then the solution that goes inside the probe, the reference solution, is silver chloride. And silver is very toxic to aquatic life, so make sure you keep track of that. Check with your local guidelines. Hopefully there's some sort of program that you can collect this waste and bring it somewhere if you need to, or they'll tell you how to neutralize it and destroy it on site. With that, I'm going to switch over to the demo portion. Okay. So for those that are planning to follow along here, we're going to start by putting on our PPE. So I have my lab coat. Excuse my squeaky gloves here. Get those on here quick. And okay, no more squeaking. All right, I'm going to start by demonstrating how to measure total soluble solids, or Brix. And I'm going to start with the manual refractometer. So if you have one of those, go ahead and get your grape juice open. You'll need a small beaker or a tube or something like that. You can either just cut the top off or something, dump it in a cup. Please don't drink it. I know it comes with a straw, but I've got mine in a little tube here. So just have that handy. All right. And then we also sent a few of the little disposable transfer pipettes. So I do want to note, you know, in the later workshops, we are going to be measuring specific volumes because that relates to some math and the calculations of how we're measuring things. These pipettes are not accurate for measuring a specific volume. So they're 1 milliliter or about 1 milliliter transfer pipettes, but they're really just meant for taking a liquid from one vessel to another without being concerned about how much is being transferred. So we'll show you those other more precise equipment later. But first thing here, got my digital refractometer, my juice. I will also need some DI water, distilled water. We have these fancy little squeeze bottles, but not to worry. If you've got some that you bought at the store, if you don't want to buy it, you can boil tap water and then let it cool to room temperature. And again, it's important to use the distilled water because it removes minerals. If you're using tap water, you might risk having chlorine in there, which can lead to cork taint in a winery if it gets in the winery. So make sure you're using chlorine-free water around your winemaking equipment, and then just best for the longevity of our equipment. So is anyone using a manual refractometer today? I saw in our pre-workshop survey, it looked like a lot of people had them and they're familiar with them. But I'm going to go through it a little bit just so that we get best practices down. So saw a couple people have them there. So I'm going to start. I'm going to open my lens cap. Get my little waste bottle here. And just give my lens a rinse. So it's been in the drawer for a few days. I don't know, maybe there's some dust on it or something. Rinse it off with my DI water, and then using my Kim wipes. If you have Kim wipes, you can order those online somewhere. I think even just Uline has them or something, or a soft lint-free cloth. Dry that off, make sure it's nice and dry and clean. Okay. And then I'm going to go ahead and calibrate make sure that my manual refractometer measures 0 when there isn't anything in my solution. So that's where I want my DI water again. I'm going to cover the lens and close the cap. And then go ahead and bring it up to your eye. Make sure you're in a good light source and look through. So what you're looking for, I'm going to try to show this on the camera. It's going to be a little bit shaky, but you can see down at the 0, it does say 20 degrees Celsius. So I want to make sure that the thing I'm measuring is at that room temperature. And then the difference between dark and light is where I want to take my reading. And it is at 0 right now with the water on there. I'm sorry, it's not super clear on the camera, but it is at 0. And then, does anybody having issues calibrating their refractometers? Any questions on that first step? No? All right, I'm going to go ahead and dry off the lens again. Make sure it's nice and clean, both parts. Make sure to dry off the cover as well. Once we put our sample on there, we don't want to dilute it. And then we can proceed with our transfer pipette. We can take a little bit of juice and cover that whole lens with the sample. Go ahead and close the cover. I see some people going over to their windows. Awesome, getting the best light source you can. Looking through. And I'm going to try to show this again. Just hopefully, if you're not using one or haven't seen this before, you'll see there's that partition between white and blue, dark and light, that has shifted up to around 5. So whatever value you got, make sure to write that down. Check it a couple times if you want to. It's always good idea just to make sure, if you're, especially if you're not familiar with things, doing it multiple times just to make sure that you're getting repeatable values. And go ahead and clean that off. And feel free to raise your hand. You can unmute if you have a question as well. Type it in the chat box. All right. I'm going to go ahead and set my manual refractometer aside, and we'll look at the digital refractometer. Does anybody have one of those with you? A little digital refractometer. They're going to operate very similarly. So this one has a little cap. I'll lift up. I'm going to put a little DI water on there just to rinse it off, clean it out. And then I can reapply the DI water. And with these, it's especially important to make sure once I close the cap, or before I close the cap, excuse me, there are no bubbles on the surface of the liquid. Hard to show with this because I don't want to tilt it too much, but I don't have any bubbles there. It's a little bit more challenging with the juice because there's other stuff in there that makes it a little bit more foamy. Just close the lid and then wait for it to pop up. And it should read 0. So if you don't get 0 on a digital refractometer, you'll have to do a calibration. And that'll be a little bit different on each unit. But you should have a manual that goes with it, and it'll tell you how to do that. Just adjust it to 0. So next, I'm going to show the digital, excuse me, with the measuring with the juice. So you can take that transfer pipette, again, popping any bubbles that are on there, and then close that and wait for it to give me a value. Good. Has anyone been thinking about getting a digital refractometer but hasn't yet? So we use these for all of our grape sampling when we're going through the season. We can bring them back to the lab and use this. It's really convenient. All right. So that is total soluble solids. We did it. We measured total soluble solids. We got Brix. Go ahead and do it a couple times. Make sure you get multiple values. And if you did happen to use both instruments, you got different values. We can talk about that a little bit later. So one more thing I want to mention before I go on to measuring pH is that, so when you do your grape sampling, depending where, when, and how you do your sampling from your vineyard, you're going to potentially affect how you get your measurements. So if you're continuously using just the edge vines, because those are the most convenient to get to, or you're low on time or something, you're only going to get a snapshot of what those vines, how ripe those vines are. So it's really good to have a plan in place where you're sampling from different parts of the vineyard, and maybe it's the same parts every time you go out. You know, if you're going out a couple times a week as you approach harvest, you know, starting after veraison, and just trying to see how those grapes are coming along. You might be sampling at the same parts. You might try to randomize it every single time. But just making sure you're getting a juice sample that's representative of your vineyard. And you can do that, you know, I mentioned with the manual refractometer, you kind of just drip on a couple drops right from the grape. You can do that. Just make sure you're getting consistent values across once you move to the next block or row or whatever. However you're going to harvest and group your vines, you're looking for a consistency across that. So any questions about the sampling portion? Okay, so now pH. This one's a little bit more technical and requires a little bit more equipment. So if you don't have a pH meter yet, definitely recommend getting one. There are different models. Again, thinking about when you're if you're trying to pick one out, choose one with an automatic temperature adjustment, or just being aware that it doesn't have one. And then there's a few different parts. So you'll have the kind of the module, the computer part, the arm that'll hold the probe. And these probes they're replaceable, but they're not cheap. So taking good care of your probe is really, really important. Couple things to note about that. So I mentioned the different solutions that we use with pH probes earlier. So the storage solution is the one in this little vial, and that's what I'm going to go ahead and take off right now. And you want to make sure when you're storing these that they're clean. You don't end up with any mold in the little vial. You know, crystals they're not the end of the world. Potassium chloride will crystallize. I've got some on the edge of my vial here, but making sure they're nice and clean and then full as well. When you put that vial on, you want to make sure the probe is actually in the solution. You can move the cap either up or just take it off. Kind of depends on what you're measuring, how much space you need. But we're going to do that. I'm going to go ahead and give my pH probe a little rinse here so I don't drip my potassium chloride everywhere. And then additionally, at the top, again, different models might look a little bit different, but most of them will have a little hole that you'll want to twist. You can see that's kind of closed there to open. We want to make sure that's open during measurement. Closed for storage, open for measurement. And that has to do with the pressure. So you want the pressure to be able to be the same inside and outside. So you want that to equilibrate to atmospheric pressure when you're measuring, because that will affect your measurements a little bit. And then that's also the port where you would add more of the reference solution. And so you can see a little bit with the probe here, kind of the top of my solution is here. Sometimes they'll get really low down here. You don't want that. You want to add in fresh solution. And that's commonly silver chloride, but it does depend on the brand. So just making sure you know that reference solution is different than the storage solution. They're made of different things and they're used for different purposes. But so there's our little pH probe. I'm going to go ahead and give it another rinse here just to make sure we're good and clean. Get all those potassium chloride crystals off of there. All right, so my pH probe is set up. My pH meter is on. First thing I want to do if I'm going to measure pH is calibrate my pH meter. They do drift quite a bit during storage, even if you just used it yesterday. Try to calibrate it every time you use it. It doesn't take too long, and it's just going to give you a lot more trust in the measurements that you're taking. So for today, I am going to start with, I have two different buffer solutions, the pH 4 that you can get and pH 7. There's also like pH 10, pH 2, all different sets of buffers that you can get. But the most important thing is to really use buffers that span the range of your expected values. So if I'm measuring something that's basic, like bleach, hopefully you're not measuring bleach with chlorine in your winery, but you know, that's going to be on the alkaline or the basic. They're going to have high pH values. I'm going to use different buffers to calibrate than I would for grape juice, which is going to have pH of 2.5, depending on where you're starting your sampling, when you're starting your sampling, to 3.5 or something like that. So today I have 4 and 7. 7 is that neutral time point, or excuse me, neutral pH value. It's always a good idea to include that one. And then we're going to go below that into the more acidic range with pH 4. So depending on the pH meter that you have, each one operates a little bit differently. Some of them will say standardize. Mine has a little button that has the letters STD on it for standardize. The one in our other lab has CAL for calibrate. So you should be able to just follow the on-screen instructions once you get to the calibration screen. But for this one, I'm going to hit the standardize button, and I'm going to start with my pH 4. And again, some of the instructions will tell you to start with either the lowest pH or they want you to start with at pH 7. It does depend. But so for this one, I'm going to start with pH 4. I have a little bit of buffer in a small beaker. If you have those tubes like I showed earlier, those work well. Just making sure that you know when you poured out that buffer and how old it is, because they will go bad, they will drift and come out of their, you know, off of the value that they're supposed to be. So I've got my buffer here, and I can just lower my pH probe right in there. So once I have that submerged, I want to keep my solution, my little vessel, whatever I'm measuring, whether it be buffer or sample, juice, wine, whatever it is, I want to keep that moving. And so I'm just, hopefully you can kind of see that on the camera. You can see the liquid sloshing around in the beaker. I'm going to keep that moving. You can do it by hand, it's just fine. But if you have a little magnetic stir plate and stir bar. That's really convenient. They'll save your wrists some motion. And when you're doing a whole lot of these, it really makes a difference. We'll see one of those stir plates. If you've never seen one before, we'll see that next week, or in the next workshop in 2 weeks, excuse me. So following my on-screen instructions, once that reading has stabilized, it tells me to press the standardize button, and then we're good to go. So I can lift my pH probe out of the solution and give it a rinse. Dry it off and get ready for the next one. Okay, so I've done one buffer. At minimum, you want to do 2. Best is 3, but just to save a little bit of time, and our teaching lab is out of pH buffer 2, so I'm going to move on to pH 7. Hit the standardize button again and wait for a stable reading, keeping that liquid moving a little bit. So it's important to use at least 2 buffers to calibrate because you can do it manually, but most of the pH meters will do it for you. It'll calculate the slope between those buffer values. And so you're really calibrating within the range of those buffers. Go ahead and hit standardize. So right now my pH meter told me my slope is outside the acceptable range. So it says between 90 and 102%. It's sort of like how well it calibrated, because the computer knows, but the pH probe might not be clean or something like that. It might not be in a good working shape. So I'm going to stop, give it a rinse, and retry that buffer, and we'll see what we get. When you're cleaning off the pH probes, making sure to get all the way around and then gently dabbing the bottom of the probe to absorb any water droplets that are there. But you really don't want to disrupt the little glass bulb that's there, because I don't know how well you'll be able to see the little bulb there, but that is fragile and it's filled with that silver chloride and the reference electrodes, and they can be damaged quite easily. So be gentle. This equipment does a lot of work for us, so want to be nice. I'm going to go ahead and re-standardize at pH 7. All right, let's see here. Okay, we've got good calibration now. I'll rinse that off again, and then we can move on to our sample. Okay, so same thing. Okay, so now I have my pH probe in my juice sample. If you have scissors and just cut the top off, might be easier. I tried to do it with the straw the other day and it kind of leaks around the hole. So it made a little bit of a mess. Okay. So I did get a stable reading, but I'm going to go ahead and do it again just to make sure everything looks good. How's it going from Texas, Chris and Julie? I think you said your vineyard's in Knoxville, Iowa, but you mentioned you were joining from Texas, so everything going well?
Yes, everything's dandy. Thank you for this
Awesome.
tutorial.
Okay. So if you're just starting to get the juice going, sometimes on different pH meters, it won't automatically switch between the calibrate and the measurement setting. So if you went to calibrate and it's giving you a little bit of trouble with the sample, make sure you hit the measure setting or whatever, so it'll go back to like a live measurement. Not always clear on each model, but all right. Okay, so I got a little bit different value the second time. I'll share exactly what those are once we share values, but I'm actually going to do it one more time. I have another tube of juice, which came from the same pouch, but is stored slightly differently. So I'm going to go ahead and measure that one and see what we get. And really, these measurements only should, they take a few seconds mostly. I'm taking a little bit longer because I'm trying to watch the screen, but if your pH meter is in good working shape and calibrated correctly, they're almost instant read. So they don't take too long to adjust and stabilize. Okay. I'm gonna go ahead and take my gloves off here, and we're gonna shift back to the slides. So it looks like we got some variation, and then we had one person replaced with orange juice. So that'll give us a different value. So let's start with Brix. 5.5, 5.6, some a little bit lower than that. So a little bit different values depending on the tools that you used. I recorded 5.6 with both the manual and the digital. It's just a little bit harder to see exactly where that line crosses with the manual refractometer, but it does give you a good estimate. But it is still worth noting if your room, dining room, winery, whatever is at a temperature that's significantly different than 68 Fahrenheit, 20 Celsius, you'll want to consider making a slight adjustment. And so to Brix, if your juice is warmer than your water, so again, that's the other important reason for calibrating, is that you'll have the same temperature water and same temperature juice or wine that you're measuring. So if your juice or your sample is warmer than the water, you want to add 0.07 for every degree Celsius difference. So if my juice was at 73 degrees, it was in the warm sunshine for some reason, and my water was at just came out of the refrigerator tap, it's probably cold. You'll want to make sure that's different. But if let's say the water's at 68 and my juice is at 73, so it's warmer, that's 5 degrees Celsius difference, or sorry, that's 5 Fahrenheit. I don't know if I can do that conversion. Let's just, for the sake of an example, it's 5 degrees Celsius difference, multiply by 0.07. that'll give me 0.35. So whatever I measured on my instrument, I want to add 0.35. So maybe some of these 5.2s, 4.95s, maybe it was a little bit warmer than what the others were measuring. And so we'll adjust that a little bit. If it's colder, you do the same math, 0.07, you just subtract the value instead. So if your sample is 5 degrees cooler, Celsius, that is, you have to do a slightly different conversion for Fahrenheit. But that conversion is on your fact sheet. So everyone got that or got it emailed. You can reference that for that math and the temperature adjustment. So pH, similar. If you didn't have an automatic temperature adjustment with the pH meter that you were using, you'll have to consider doing a temperature adjustment. But the pH meter with calibration is really important. So we're kind of getting values, let's see, 3.43, 3.44, up to 3.58, and then down to like 3.38. So if we go from 3.38 to 3.58 in that range, I think those are our most extreme values. That's our 0.2 difference. And we talked about how a difference of 0.2 in pH is going to have consequences for our winemaking decisions, especially around sulfur additions. That's kind of the thing you'll have most direct control over, like as far as making a decision. If you're talking acid adjustments, that you'll want to consider titratable acidity as well, which we'll cover in the next workshop. So I'm not going to talk too much more about that. So additionally, we can check, can't really check for our pH, but for the Brix, we can check the nutrition facts label, which is not on the pouch. It's on the box that the pouches came in. But when I measured as a sample 2 weeks ago or something like that, and I checked that, it was 10 grams per serving or something. I don't remember. Anyway, 5.5 Brix is 5.5%. So that's 5.5 grams per 100 milliliters. And these pouches are 200 milliliters. For orange juice, if you have the facts label there, does it match the carbohydrate content? And we can talk about conversions too, if it gives you a value that, because it's going to be per serving, it might not be exactly the percent value that you got. And again, the measurement of Brix is all the solids that are dissolved. So if we just consider it based on the total sugars, it might be a little bit off. But if we look at total carbohydrates, again, we don't really have a measurement of acidity on the label or acid content, but it should be close, and it looks like it is. So a couple other just quick notes about why we might have gotten different values: the age of your pH probe, age of your buffer solutions, making sure they're in good working shape, cleaning, making sure it's clean in between samples, just so that we're not diluting anything. You've still got a lot of water that's being held up under that pH probe, and you put that into your sample, you're getting a little bit of a dilution there, which is another reason you really want to keep it moving. Hydrometer looks like 5. I want to just kind of start winding down here. I want to start by thanking Iowa State University Extension and Outreach for their support with funding. Dr. Waterlow and I work closely on this, but I appreciate her giving me the opportunity to participate and host this workshop. It's been a lot of fun putting everything together. Hope you learned something, refreshed your knowledge on pH and Brix. If we don't get all of your questions answered, please feel free to email us. We'll get back to you with an answer there. So looking forward to the next workshop, we're going to be looking at titratable acidity. So a different way of measuring acidity in your products. Measure something slightly different than pH. So it is very important to think about both of them. Some might already have a setup for measuring titratable acidity with a burette and their sodium hydroxide. If you don't, make sure to get some of that 0.1 normal sodium hydroxide, restock or see where you can get that. Email us if you have questions about sourcing that, but hopefully if you've got an operation established, you kind of know where to get those things, but if not, please feel free to reach out to us. So thanks, everybody. Have a wonderful rest of your day and look forward to seeing you next time.